Hello friends, grab your coffee, grab your cookie, and keep both away from any jewelry polishing machine, because today we are talking about bronze dust, silver dust, and gold dust. Yes, 3 very expensive ways to clog your filters, coat your equipment, and violate every section of NFPA 484 if you are not careful. My name is Michael Klepik, and for 15 years I have been designing air filtration systems for metal finishing shops, jewelry manufacturing, casting, polishing, grinding, and precious metal refining. Let's talk about why even luxury dust can be hazardous. What these metallic dusts really are. Technical description: bronze, silver, and gold dusts are generated during cutting, polishing, grinding, filing, tumbling, melting, or refining of metal components. Technically, first, particle sizes typically range from 1 micron to 100 microns. Second, the most airborne fraction is usually below 20 microns. Third, bulk density is extremely high, often between 4,000 and 8,000 kilograms per cubic meter. Fourth, metallic dust may contain alloying elements such as copper, tin, zinc, or trace chemicals from polishing compounds. Fifth, all 3 are electrically conductive, which increases static discharge hazards. These dusts may look small, but they behave like heavy metallic smoke. Where these dusts appear in industry, you will see bronze, silver, and gold dust in first, jewelry manufacturing and polishing rooms; second, third, electronics and contact plating; fourth, casting and metal finishing shops; fifth, grinding and buffing of metal parts; sixth, recovery and refining facilities for precious metals. Anywhere metal is shaped or polished, dust appears. Hazard summary: bronze, silver, and gold. Each dust type has its own risk profile. Bronze dust first, contains copper and tin. Second, copper dust can oxidize and cause irritation. Third, many bronze alloys are combustible in fine powdered form. Silver dust, first, conductive and highly reactive with sulfur-containing compounds. Second, can ignite if extremely fine and exposed to heat sources. Third, causes strong tarnish and corrosion buildup. Gold dust first, chemically stable but electrically conductive. Second, very fine particles can ignite under certain metal dust conditions. Third, high cost requires efficient recovery and filtration. All metallic dusts must be treated as potentially combustible under NFPA 484. Physical behavior of precious metal dusts in airflow. These dusts behave differently from organic dust. First, they are heavy and settle rapidly if airflow is low. Second, extremely fine fractions remain airborne like smoke. Third, conductive particles accumulate static charge. Fourth, bronze dust can oxidize and create fine reactive layers. Fifth, dense dust loads can erode duct elbows and fan blades. Because of their weight, I designed duct velocities from 4,500 to 5,500 feet per minute. Combustibility and NFPA 484 compliance. According to NFPA 484, standard for combustible metals, fine particles of bronze, silver, and gold may be combustible depending on: first, particle size; second, alloy composition; third, surface oxidation; fourth, dust cloud concentration; fifth, ignition source proximity. OSHA also regulates metal dust hazards under the General Duty Clause, requiring dust hazard analysis and proper engineering controls. Even precious metals can explode when airborne in fine form. Filtration equipment that works best for fine precious metal dust. A FOEHN cartridge collector is effective. First, high-efficiency media captures fine metallic particles. Second, conductive and anti-static filter media prevent ignition sources. Third, large filtration area increases the recovery of valuable dust. For heavy polishing or grinding dust, a Baghouse blizzard is suitable when: first, dust loads are high from polishing wheels. Second, metallic flakes and fibers are present. Third, dust contains abrasives mixed with metal. Both systems can be configured to support metal recovery. Explosion protection and grounding requirements. Metal dust systems require strict protection measures. First, explosion venting where NFPA requires it. Second, properly rated isolation valves. Third, conductive filter media to dissipate static. Fourth, full grounding and bonding of ducts and collectors. Fifth, no plastic ducting permitted for conductive dusts. Sixth, hot surfaces must be eliminated around metal dust equipment. Conductive dust plus static equals ignition. Capture hood design and dust recovery. Efficient capture is essential because precious metal dust is both hazardous and valuable. I always use: first, enclosed polishing and grinding hoods; second, slots and plenums near buffing wheels; third, capture at jewelry casting sprues and gates. Fourth, direct pickup at tumblers, vibratory finishers, and rolling mills. Fifth, dust discharge systems designed for easy metal recovery. A well-designed hood saves both safety risks and material losses. Bronze dust, silver dust, and gold dust may come from beautiful materials, but the dust itself is anything but beautiful. It is conductive, often combustible under NFPA 484 conditions, highly airborne in fine form, and capable of damaging both lungs and equipment if not controlled properly. With strong airflow, high-efficiency filtration, explosion protection, proper grounding, and OSHA and NFPA compliance, we can keep these facilities safe, while also recovering every valuable particle. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, precious metals belong in your safe, not floating in your ductwork. See you in the next video.